All right, so this is a talk called Async Redux Actions with RxJS. I frequently get asked about what's better, Redux or RxJS. They're good together. This is a love story. That's why we had music. Also because I like it, I'm weird. Who am I? I'm Ben Lesh. I am the RxJS 5 project lead. I'm also a senior engineer at Netflix on the UI platform team. You can find me on Twitter at Ben Lesh or on GitHub at blesh. So really quick, and I know that there's been a lot of talks already that have kind of gone over Redux or talked about Redux, so there's just lots of material in general on it. If I'm talking about Redux with RxJS, we need to know what Redux is. So if you missed that, very, very fast. I actually didn't know what Redux was. I didn't even know how to pronounce the word when I first saw it. So the first thing when I saw it was like, red UX, what's that? Making your whole site red? That's pretty cool. And then I was like, well, maybe it's a shelter specializing in abandoned ducks, or a startup for bioengineered foie gras. That's duck livers, I don't. Or an evil recycling program for unwanted ducks. That's sad. So let's get serious here for a minute. It's Howard the Duck. I actually had to remove a lot of duck pictures from my talk. Well, what Redux really is it's a library for managing state with reducers. It's basic functional programming wizardry brought to you by Dan Abramoff and friends. So it's fantastic. I like it a lot. But a reducer, what's a reducer? So really quick, what a reducer is, it's a very simple function that takes state in an action, and you produce new state with it. So that's all a producer is, or a reducer is. So it comes in a few forms. One form is you get a state and an action, and you decide, I don't want to do anything with this action, you just return the same state. Another form is where you get a state and an action. In this case, the state, I guess, is an integer or something, and you return a brand new state. The final form you probably don't want to do, and I'm not even going to show it on here because you don't want to do it. That's where you mutate the state and return it. There's, I'm sure, talks about why you shouldn't do that with Redux. Reducer in Redux looks like this. What you have is you get the state in, you initialize it. In this case, it's being initialized to a new object with a value. And usually inside there, so actions always have a type. And there's usually inside of here, there's like a switch statement or a bunch of if, then, else type things that are looking at the type and making decisions about what state to return or how to change some value and return a new state. That's it. So this is the idiomatic Redux example you'll see in every Redux tutorial of increment and decrement. So reducers are a really great way for managing state. You get an action, you dispatch an action, and it notifies you that you've got some sort of change, and then you return a new state. It's very, very simple. Reducers handle state, they handle the state transition, but they do all of this synchronously. They have to be synchronous. You can't get an action in your reducer and then turn like a promise to some state later or like anything else. You have to return the state that instant. So that leaves some kind of fuzzy space of like, what do I do when I have some asynchronous thing and I'm using Redux? We've got a lot of types of asynchrony in our web applications. One is user interaction. So these would be things like your mouse movements or clicks or keyboard presses, that sort of thing, or touch if you're dealing with mobile. There's things like Ajax, so making an HTTP request to get some data. WebSockets, so a persistent connection where you're getting a stream of data. Animations, workers, other things. So these are all things that you might want to be programmatically notified about and then dispatch some sort of action to update your state or update your view. A lot of these things can be handled synchronously, actually. There's not always a case for really complicated async handling. So for example, if you're going to click a button and just update the view immediately for like our increment decrement example, or just select something from a dropdown and update the view, you can do that right from the handler. Just dispatch an action, update your state, you're fine. If you're handling an Ajax request, it just comes back. You handle it, you're fine. Most things, I'd say probably 95% of what you do can be handled with just Redux, and you probably don't need anything super fancy like RxJS. But some async is a little bit harder. So these sorts of things would be like Ajax cancellation. So you send out some request, and maybe there's multiple ways that you want to cancel this thing, like a button click or maybe a route change or something. Composed Ajax, so I think we've all hit this maybe once or twice, where you have to send out a request to get some information from one service, look at it, make a decision about what the next request you're going to send out is. And you have to do that one after the other. So that gets a little tricky. You might have error handling and stuff in there. Debounced or throttled form submissions. So this is a form of like rate limiting on the client. So maybe it's not a form submission. You just don't want someone spamming, clicking a button over and over again and like spamming your server. So you've got some sort of timer in there to make sure they can only do one click every so often. Drag and drop. So this one's actually more complicated than it always sounds. Everybody's like, drag and drop. It's easy. It sounds easy. To implement, it's not easy. You've got a mouse down, and then after your mouse down starts, you want to start listening to mouse ups and mouse movements. And when you get a mouse up, then you stop listening to both of those things. Gets a little complex. Advanced WebSocket use, so this would be things like dealing with multiplexed WebSockets, where you're getting multiple data streams over a WebSocket. So these things all have a few things in common, all of these more complicated async tasks. One is they're all composing multiple async sources. So the drag and drop is a perfect example of that. So you're only really listening for mouse down on something at first. But when you get that mouse down on this target thing you want to drag and drop, now all of a sudden you are like, well, wait, let's add an event listener for mouse movements and mouse ups. And when you hit a mouse up, you're like, OK, I can stop listening to those two, the mouse ups and the mouse movements. Which brings us to the next thing they have in common, which is cancellation. You want to be able to stop your async values from coming in. So those are common amongst all those other examples I just showed you. So in Redux, the best thing you can do to manage async when you need to really manage your async is to use middleware. And there's lots of middleware available. I'm about to talk about Redux Observable, but there are other things, Redux Saga, Redux Thunk. They all have similar benefits. So most Redux middlewares use callbacks or promises. Some of them use generators, but a lot of generators are very imperative. If you watched Brian Lonsdorf's talk yesterday, you'll know why I tend to favor declarative over imperative. It's a great talk, by the way. You're welcome. But yeah, callbacks and promises are common throughout everybody's web applications anyways, right, these days. So I want to talk about these really quick. So callbacks, we use callbacks all over the place. Callbacks are very simple. You have a function that you call with another function that is your callback function. It will be called whenever your async task is done, usually with some data, maybe with an error or something. And then you would perform your task in there. In this case, I'm dispatching. The problem with callbacks is, there's a few problems. One is you hit Callback Hell, which I like to call the flying V because it makes this cool like wedge shape. So it's like a contest to see if you can get over your 80-character limit with that. The other problem that you can't see in here, it's kind of hidden, is how are you going to propagate errors through this? Like, you know, if there's an error that happens in the middle there, like what do you do with it? So those things get a little bit more difficult with this sort of thing. Promises actually provide a better solution for both of those problems. Promises would take that previous thing I just showed you, and it flattens out that flying V into these nice then clauses. So do this, then do this, then do this, then do this. It's definitely more declarative, which is nice. Promises come with a few other things, but a few other problems. But the good stuff about promises are these features here, which are they're a guaranteed future, they're immutable. It's not going to like change. Some other process isn't going to change it on you while you're waiting for it. It's a single value, and it caches. So I actually really like that promises are a guaranteed future. I think that's a kind of a powerful feature of promises. But these two things are actually problematic in modern web applications. Guaranteed future and a single value. So why is a guaranteed future problematic? A guaranteed future is problematic because that means that promises cannot be canceled, which means you're probably executing some code you didn't want to. I'll set this down here. I'm a little worried about dumping it on my laptop. You're probably going to execute some code you didn't want to. And you want cancellation. Cancellation is important. So here's a few just like really minor examples of where you might want cancellation in an app. You probably want it in a lot more places than this. But so autocomplete. And this is the thing that everyone shows an example of with Rx talks. Autocomplete is where you're typing in a text box. And then on key up, you're probably throttling or debouncing or something, but you're sending an AJAX request to get some data for recommendations for what to put in that text box, right? And that means that you're probably sending off a lot of AJAX requests, and sometimes you're going to send one off before the previous one gets back. And so you'd like to cancel the previous one if you can. Changing views and routes, and I'm going to show an example of this in a bit. If the data from one route doesn't arrive before you go and change to the next route, you probably want to be able to cancel that. And then the other thing about cancellation is we have to remember it can tear down resources, which is a very powerful tool. You can send unsubscription messages over WebSockets. You can tear down event listeners. It's a powerful way to kind of compose in behavior. So here's my example. Mr. Kent C. Dodds was foolish enough to allow me to use his images or pictures of himself in my talk. So that's Kent Chimichanga Dodds. He's here somewhere. So he's going to use my hypothetical Netflix UI. This is not a real Netflix UI. Well, it's a recording of it, but what I'm about to explain is probably not exactly how it works. He's going to go and he's going to say, I want to watch me some Daredevil. So he clicks Daredevil, and we send off this AJAX request to get some metadata about Daredevil. And before that even comes back, Kent's like, I'm indecisive. I'd rather watch The Get Down. So he clicks that guy. We send off another AJAX request. Now we've got a problem. We've got two in flight. One of them we care about, one of them we do not. We don't care about Daredevil anymore. We're on to the Get Down. But the server, being the reliable Netflix server that it is going to respond with that Daredevil metadata. And what's going to happen is that XHR, which is your XML HTTP request, the underpinning of AJAX in your web browser, is going to say, oh, that's great. I know what to do with this. I'm going to read the headers, and I'm going to make decisions based off those headers about whether or not I should take all the JSON and parse it into an object. And I'm going to block your thread while you're parsing that JSON. It's going to be wonderful. And that uses Kent C. Dodds' system resources, and he makes a face like this, which I think he's actually yawning, but it's so contorted. I love it. And then there's sad pandas everywhere because you can't cancel that previous promise. And in fact, the other thing that's worth noting here is, as a developer, the pain point is you're going to have to then manage which one of your promises you actually care about if you have this promise-based AJAX API. You can't rely on just, oh, the last one I send is the one I care about, because sending out AJAX requests is non-deterministic. They could come back out of order. There's no guarantee they'll come back in order. They usually will, but that's not always the case. So that means that each individual request that you send out, you're going to have some sort of disinterest Boolean check inside of there for which one you care about. So a better scenario would be if he was like, let's watch me some Daredevil. We send the request. And then he's like, nah, let's watch the Get Down. And he sends the next request, and we immediately, as soon as that next request is sent, we just cancel. We abort the XML HTTP request for that one. And that means that, first of all, one explanation is if you abort an XHR, it's not going to cancel what your server is doing. Your server is still going to process that request and send it back. It would be a tremendous security hole if you could control the server from the client like that, anyways. So it's going to come back, but the browser's going to take it and just drop it because it no longer cares. It's not going to examine headers or try to parse JSON or any of that. So this is ideal. This is what we want. Thanks, Kent C. Dodds. He's in here somewhere. He's an upbeat guy. You should talk to him. But these days, so you're doing this to save resources, but these days resources are so cheap. Like, why do I care? Like, I've got this crazy laptop and all sorts of memory, and that's kind of the boat that a lot of us are in, or what we think about, but that's not always the case. And this is just in Netflix's case. Netflix targets some devices that are 465 times slower than your laptop. So those little things that you're streaming on, you want those nice fluid animations and stuff, like that's what those poor people in like TV UI and stuff have to work with. Really, really underpowered stuff. But that's just Netflix. That's not everybody. But times are changing. I think that it's not going to be long until everybody in this room has to deal with something like that. Right now, everybody's using laptops and desktops mostly for their productivity app type things. But a lot of people are using tablets and smartphones. I feel myself using those more and more. There's things like industrial devices and smart TVs and appliances and wearables that now have web apps running on them. They've got little browsers, and it's amazing. But they have really underpowered CPUs and very little resources. So it's always good to consider your resource usage across the board. The other thing I said could be problematic with promises is that it's a single value. This isn't as big of a deal, but it would be really nice if we could use an async type that we could represent most of our problems with, if not all of our problems with. And if we look at our types of asynchrony we have in web applications, only one of these is really actually a single value. I mean, maybe you could make the case that animations, like you only care about when it's done, but you might want updates in the middle there, so that's not a guarantee. So really, it's just Ajax. Ajax is the strongest use case for a promise. But like I said, I wanted to be able to cancel it, so not great. So what do we use? What do we use? There's another duck. I love the ducks. Love the ducks. We want to use observables. And I probably wouldn't be standing in front of you if we weren't talking about observables, being that I work on Rx. But what an observable is it is a set of events. And you can think of it as any number of values over any amount of time. And it's got cancellation, so it can tear down whatever's producing those values. And it's lazy. That means it won't do anything until you subscribe to it, at which point it sets up whatever's producing those values. So very powerful. And RxJS is actually all about observables. So it's methods for creating observables, methods for composing observables. It's the bread and butter of what RxJS really is. Another way to think about it is Lodash for async. So when I start showing examples, you'll see chaining these functions together. It will look a lot like Lodash. So a few examples of how you can create observables with Rx. Just real quickly, you can create an interval, a stream of events that's happening over time. At the top there's from event, you can create them from DOM elements. Probably not going to do a lot of that in React, honestly. You can convert any iterable or promise or observable-esque thing with from. You can just have a value or a series of values. There's Ajax helpers, there's WebSocket helpers. There's a lot. There's a lot of ways to create observables with Rx. What an observable looks like if you were going to go to use it manually is you would just call subscribe on it. When you call subscribe, that's when it actually starts working. An observable is inert until you do this. And the first argument that you would pass to it is your next handler. And that's just going to handle every single time it pushes a value at you. This method is called with that value. The next thing that it gets called with, the second argument, is an error handler. So this looks a lot like promise then already, where you have success and error. The error handler gets called if there's an error originating from anything inside the observable. And that'll be called, then the observable is done, and it will call your teardown logic for you automatically. And then the final one is your completion handler. This is saying, I'm done successfully. I am notifying you that I'm complete and I have not had any errors. And that'll also call your teardown logic after this fires. And then when you call subscribe, you actually get a subscription back. And the subscription is for you to hang on to, so at any later point, you can call unsubscribe, and that's you notifying the observable, say, hey, stop sending me stuff. And that's your cancellation. This is actually the imperative way to cancel an observable. I'll show the declarative way in a little bit. So we have a set of events that we can cancel. Pretty cool, but now what? So like we talked about how we have these problems in async. What can we do with these sets of events? Well, since they're sets can be transformed. So think about like an array. Like all of these exist on array: map, filter, reduce. It's set mathematics that you can do some of these things over sets. The other thing you can do with sets are you can combine them. You can take two different sets, two different observables, and combine them. You can concatenate them. You can merge them. Merge them would just kind of mesh them together. Zip is something you might have seen in Lodash, where it combines them kind of by index. So observables, though, are unique sets because they actually have another dimension. So they're not a one-dimensional, like linear set of things. They also have this dimension of time. So there's other actions you can take with a set of things that happens over time. You can buffer them. You can throttle or debounce. You can combine the latest values from two. There's an element of time. So that kind of inflates the number of things you can do. Since they're lazy, you can resubscribe. So if you have an observable and it fails, you can subscribe to it again and see if it works the second time. So that would be our retry. The other thing is if it completes successfully and you're like, that was great, I want to do that again, there's a repeat operator you could use. These are just methods on observable. Also, it has an error path, just like promise, so there is a catch, exactly like promise. It doesn't look very much different. You could, in fact, actually even return a promise in there if you wanted. Rx would eat that. So you can really do just about anything with RxJS and observable. So if you can imagine what you can represent with a primitive type that embodies the setup of something that produces data in any number of events over any amount of time, even if it's instant or no values, and then embodies the teardown of that thing that's producing data, that's a lot of stuff. You probably do just about anything in computer science with that, almost, except for data structures. That was a different talk. In fact, you can do so many things that, this is from the Redux documentation, some say it's a two-liner using RxScan to build Redux. This is, again, like I said, it comes right from the documentation. It is true, you could use RxScan to have the behavior of Redux store. You could totally do that. I've seen people use it like that, that's fine. And that's great. But I actually would rather use Redux because Redux has amazing tooling. It's got great community support. And honestly, it also provides a lot of really solid architecture patterns, Redux does. That's probably the biggest selling point of it, in my opinion, especially if you're using it with middleware. So I'm going to show you some code here. I don't want you to read it all. It's probably going to be too small to read anyways. But just to look at what happens if you're trying to use Redux to do an autocomplete, just an autocomplete component in React without any middleware, so with nothing, and you can't read it anyway, it's all blurry. But it's going to look a little bit like this. You're going to have all this code. And actually, I snipped some boilerplate out of the top of the component here. But you'll have a reducer. That's not really going to change. But in your component, you're going to have interesting things. Like you're going to have some instance state. And this is going to be to track your last set timeout that you fired, one to track the last XHR that you newed up and sent. You're going to have a handler for your key ups that you're using to kick off your async. This stinks a little bit because that means you're not really dispatching something to handle this. You're just executing it there. And incidentally, this stuff is fine. This is fine, but you'll see the advantage, hopefully, in the next slide. And then you're going to have this render function. This is arguably the most important, if not maybe the only important part of your component. This is the thing that actually renders the view. So if you're using middleware, especially if you're using react-redux, which is a way to tie Redux to React, it's a great project. I've snipped some of the React-Redux boilerplate out of there. It's like maybe 7 lines. But it's going to look like this, and it's going to be a little bit more organized. So we're going to have an epic in this case because we're using a Redux observable middleware. So this is like middleware functionality that handles all of our async logic. Reducer, which is handling all of our synchronous updates of state. And then we have the stateless component. Like we've taken all of that other logic and we've moved it out of our component. We don't have state in our component anymore, which means that our component is just a render function. And I know that this is React Rally, but in reality, this means that if you decide at some other point, like I've got all this logic, but I really want to use something else to render this, some, I don't know, native mobile thing or some other framework or whatever, you can do that now because all you were using React for is just to render your component. Just to render your view. So what we really want to do is we want to have this middleware that combines RxJS and Redux, because we can see the value of middleware, and we can see the value of Redux in RxJS, hopefully. So what we do is we smash the duck, and we just slap the Rx logo on it. And that's what we did. And we came up with the Redux observable. There's this logo. By the way, I proposed this logo, like a pencil drawing that I made on like a Post-it note at Netflix, as the logo for Redux, and it was rejected. So, haha, I'm using it now. So, epic middleware for Redux. You're going to hear me say epic a lot. It's not that I'm being a hipster. It actually is a term that was really just bike-shedded to death that we ended up using for what we use in this. So, what is an epic? An epic looks like this. It's just a function. And it's a function that takes a stream of all the actions that have already been dispatched to your reducers. And it also gives you a second argument for a store if you need it. I don't think any of my examples actually need it. And what you do is you then return, you have this observable of actions. You're expected to return an observable of new actions that you're going to dispatch. And since observables are asynchronous, that means you could add some delay in and then dispatch something. In this case, I'm doing something totally synchronous. And I'm saying, hey, every time I get a dispatch action of type ping, let's dispatch an action of type pong. But this is just a function. This function just returns an observable, and observables don't do anything until you subscribe to it. But the middleware does that for you. So let's look at how we set that up. Oh, first, another way to look at an epic, just to simplify it, is actions in, actions out. It's a function that you could just take that store out of there, and it's just actions. So this is how we use it with the middleware, basic middleware setup. If you've never used middleware with Redux, this is how you basically use all middleware. You import, create, store, and apply middleware from Redux. And then the other thing you have to do is you import create epic middleware, which sounds so amazing. The middleware is not that big. It's not very epic, but it's wonderful. You import create epic middleware from Redux Observable, and then you also bring in your reducer function that you use for Redux, and you bring in your epic function, which is just this guy that I showed you. It's going to be shaped like that. And you take your epic function, you pass it to create epic middleware, and it will then create the epic middleware, aptly named. And then you pass that to apply middleware as the second argument to your create store. And so after that, every action that's dispatched to this store, after it goes through the reducer, will show up in your epic. It'll be pushed out of that actions observable that epic provides you. So let's talk a little bit about, so I showed you earlier the idiomatic increment, decrement. So it looks like this, just to jump forward. That's when you're doing I'm clicking a button and I'm incrementing a value, classic Redux example. But what if I wanted to debounce those button clicks? So if I wanted to debounce those button clicks, maybe I have them dispatch up or down instead. And I'm going to intercept all the actions of type, well, I'm not intercepting them, I'm taking all the actions of type up, and I'm using debounce time on it, which basically just says, hey, I'm going to wait for a full second since the last value I got before I let anything carry on to map there. And then once it does allow something to go to map, it's going to map it to a new action of type increment, and that will be dispatched on your store, which is then going to hit your reducer and update your state and then update your view. So that now looks like this. This is a screen capture. You can see I click the button multiple times, and it waits a full second before it actually does it. So I've kind of got some client-side rate limiting on my increment, decrement. This is the app we're all writing today, right? This is really important functionality. If I have my way, this is going to show up on Netflix for sure. So again, another warning, don't read all of this code. What I want to show you is kind of the example of just a very high level of why use Rx to do these sorts of things over imperative code, which in my mind might include some things that use generators and stuff like that. So here is what an autocomplete example, this is just a snippet out of a component, an autocomplete example in plain JavaScript. Very similar to the example I just showed earlier. And it's a lot of code compared to this. This is the autocomplete example in our epic. Now, one thing I want to note is in this example, I'm not actually dispatching anything that says, hey, I want to load a query. So it's less testable. It's much more testable if you have something where you're like, I'm going to dispatch an action that says I want to get a query from Ajax or whatever. Here I am. I'm dispatching an action of type load query. And every time that happens, I've got my debounce on there, and I'm using this switch map to make my Ajax request. Switch map has an implicit cancellation semantic to it. So it has that behavior I showed earlier with the Kent C. Dodds example, where we had a request go out, and if it's not done yet, switch map is going to say, well, I've got a new one, so let's use that, and I'll just cancel the old one. So that's what switch map does. So there's an implicit cancellation there. But let's say, for whatever reason, you want to add a button to your page that cancels this autocomplete request, or you want to cancel it when you do a route change or something, you can dispatch any other action and then just use take until. So take until is the declarative way to cancel your observable, so as opposed to using subscription.unsubscribe. So this is the better way to do it. Now I can dispatch, anybody can dispatch cancel query, and if there's one of these in flight, it's going to kill it. There's another one. Don't read it. You can't anyway. It's too small. Multiplexed WebSockets, plain JS. So just again, to explain why this is a difficult problem, A multiplexed WebSocket is a single socket on which you're sharing multiple data streams. That means that when you want a data stream, you have to make a decision about whether or not you need to connect the socket. Then you connect the socket, then you have to send a subscription message to the server once it's connected. You have to filter out all of the values that are coming to you for that specific data stream. And then when you want to do another data stream, you have to say, oh, well, is the socket already open? It is. OK, send the subscription message, filter out my data. When you want to close any data stream, you have to make decisions about, you have to send an unsubscribe message when you close it, and then you have to make decisions about whether or not to close the socket itself, depending on how many data streams are still listening. So there's some reference counting in there. And it gets even more gross if you want it to stay connected when you lose network connectivity. Because think about that. Your network goes out, you lost your WebSocket. Now you have to reconnect the WebSocket and make decisions about, well, what was I subscribed to? OK, well, we'll reconnect the WebSocket. Once it's connected, which is an asynchronous action, by the way, we're going to go ahead and send these subscription messages and start filtering data out again. So this is all the code you would have to write to do this. There's probably bugs in here. It's got a lot of state management, and it gets crazy. This is what it would look like if you did it in Rx with an epic. So really, again, you don't need to grok all this, but there's about 5 lines, maybe like 5 lines in there where there's like socket.multiplex. That's all of the multiplexing logic is right built into that. It comes out of Rx. There's a block in the middle there for retry when. That's everything that is responsible for saying, oh, well, I need to retry this whole WebSocket thing if I lose my network connection and so on. And then there's a take until at the bottom that is for receiving messages about canceling specific data streams and just killing that. So a lot less to grok. But let's talk about the good and the bad of this to kind of wrap it up. So the good of this is it makes it really easy to compose these very complicated async things because you've got the power of Rx. You can use Redux tooling. Redux tooling is great. There's a lot of really awesome Chrome extensions and Firefox extensions to help you work with Redux. You can dispatch actions. You can see what the state is in your store. There's great things like hot reloading and all this other stuff. You don't want to end up managing your own Rx subscription. So I know I showed you how to imperatively deal with unsubscribing. But you'll notice in all of my epics, all of my Redux observable examples, you never have to do that. Because the middleware does that for you. If you find yourself manually managing subscriptions, you might be doing something wrong. So if you use it with something like react-redux, also, you end up taking all of your async and synchronous logic and moving it to these abstractions that are very easy to test if you follow all the Redux patterns, which I actually didn't in my example. My example, I'm sure Dan Abramoff was going to see this and shake his head. But, or Jay Phelps is in the audience. He's definitely going to shake his head. So yeah, if you follow those examples, I mean, it totally isolates those things from your rendering, from React itself, which makes everything a lot more testable, a lot more flexible, and honestly, a lot less code for the most part. The bad, though, and I say this in a lot of my talks, don't, never let anyone get up here and be like, oh, I made this thing and it's amazing, there's nothing wrong with it. The bad about this is, one, you're going to have to know Redux in advance. And I think everyone here, if you really like React, should probably, at the very least, learn Redux. It's got some great ideas. It really does. The other thing, the harder part of this is you should really learn RxJS before you start doing this. I wouldn't recommend trying to learn RxJS as you're doing this. You could. But RxJS, just for reference, has 60+ operators at least. Only 8 to maybe 12 of which you'll end up using most of the time. But I mean, I wrote a lot of that, and I'm telling you right now, it's something that's not easy to learn. It's a domain-specific language within your app. Once you learn it, then reading these epics, right now they look kind of confusing, but once you learn it reading these epics, you're like, oh, I know exactly what's happening here, and it's very terse and nice and expressive. But there is a learning curve to that. So in a plug for the sponsors of this conference is they have fantastic tutorials on both Redux and RxJS on Egghead.io. They really do. So Dan Abramoff, I think, did a lot of the Redux stuff, and I did some of the Rx. So Redux Observable is actually, it's open source, so it's available on GitHub. And I really, really would like to thank Jay Phelps, who's here today. You can ask him all the hard questions about this. He's the brains. He's a co-author of this with me, and I'm really, really thankful that he's worked on this with me. And that's it. That's all the ducks.